Hi children, hope you all are fine at home. This is Ramya, working as TGT Science in Basic Welfare School, Vemludevi. So, we are going to discuss today regarding the topic Tyndall Effect. This is one of the property we are going to discuss for solutions, colloids and also suspensions. Yes, Tyndall Effect. The solute is completely dissolved in the solvent. Like examples are sugar in water, salt in water, then alcohol in water, and also potassium permanganate solution, copper sulfate solution. These all we know. Yes. Now, along with that, the heterogeneous mixtures where the composition is non-uniform means we can see the particles separately and they are not completely mixed. But in colloids, we cannot see the particles separately, even though it is a non-homogeneous mixtures or heterogeneous mixtures. In colloids, the particles are very small, they are invisible for our naked eye, so we cannot find the difference. But in suspensions, the particles are visible for our naked eye, so we can find the difference that it is a non-uniform mixture. The particles are not completely dissolved in the solvent. Examples of suspensions we already know that it's muddy water. Yes, then what else can be? Oil in water, chalk powder in water, then pepper powder in water, which and all they are not completely mixed. We can see the solute and solvent separately or the components of the mixture separately. That is what? Suspension. Yes, right? Now when we talk about colloids, it is also non-uniform, but they are invisible for our naked eye, but they are visible for the microscopic eye. So now solutions in colloids are similarly seen, right? Like milk and blood, they are colloids. Yes, but they look almost similar to the solution. Why? Because their particles are not visible. Okay. So how can we find the difference between solutions and colloids? We can find the difference between solutions and colloids by Tyndall effect. Yes, this is the property we are using here to find the difference. So here are some examples of colloid systems. Like we can see foam, milk, fog. Fog means pogamanchu. And the detergents when the bubbles are coming, and the blood, paints, milk. All these types are examples of colloid. So today's topic is about Tyndall effect, which is mainly nothing but the reflection caused by the reflection of the light by very small particles present in colloids and suspensions. Okay, when the light pass into the matter, mainly colloids and suspensions, the light is getting scattered. స్కాటర్డ్ అంటే అది ఎలా పడితే అలా వెళ్తుంది అనమాట. దాని పాత్ మనకి విజిబుల్ అవుతుంది. సో వెన్ ద పాత్ ఈజ్ విజిబుల్, దట్ effect is called Tyndall effect. So when the light passes into the matter, nothing but colloids and suspensions, the path of the light is made visible by this matter. So you can often see this Tyndall effect when mainly colloids are present. We know that dust in the air comes under colloids. Yes, so when the sunlight is coming into the window, which is only very slightly opened, yes, we can see the dust particles. Yes, so that is mainly Tyndall effect. And also the clouds, through the clouds we are able to see the light, sunlight. And also mainly any other colloids are coming in the path of the light, we can clearly see the Tyndall effect is visible here and there everywhere in our daily life. So when we are seeing the early sunlight through the canopy of the trees or through the fog, we can see the path of the light visible. Yes, that is due to the Tyndall effect. And what is the colloid there? The colloid is fog and also the gaps in the. So here we go. Once again, the definition of Tyndall effect. The scattering of visible light by either colloid or suspension particles is called Tyndall effect. In Tyndall effect, we can see the path of the light. Okay, so this is majorly seen in colloids very clearly and is also seen in suspensions when the suspension is not settled down. Means when the heavy particles of the suspension are down, ఆ మట్టి ఏదైతే ఉందో నాన్న అవన్నీ కింద ఉన్నప్పుడు the Tyndall effect will not occur. When we stir it or when the suspension is disturbed, it's not settled, then we can easily see the Tyndall effect in suspensions also. Okay, so now how we can differentiate using this Tyndall effect the colloid suspensions, mainly the solutions and colloids. But while looking solutions and colloids, they look uniform. Yes, milk, blood, all those look uniform. We cannot see the one more separate particle in that, like how we can see mud and water, oil and water, yes, some chalk powder and water or chili powder and water, like that we cannot see in colloids the separate particles. But even though colloid is a heterogeneous mixture, because the particles are not visible for our eye, and in solutions also particles are not visible for our eye, but there is a size difference between the particles of colloids and solutions. Solutions particles are very small, so they cannot scatter light, ante avi light direction ni marchalevu, they cannot reflect light. Okay, now what about the colloids particles? Their size is enough for the reflection of light. So what is the major difference, Nana? Here colloids will scatter light, solutions won't. Now we understood that colloids and suspensions will scatter the light, means they show Tyndall effect, but solutions are not going to show Tyndall effect. This is one of the major difference between solutions and colloids. Now what about colloids and suspensions? Both are showing Tyndall effect, but in suspensions the particles are visible for our naked eye, and in colloids they are non-visible, they are invisible for our naked eye. So this is the topic Tyndall effect for today. Thank you.